All right, cool. Hi everyone. My name is Kevin. That name is not supposed because I helped make the LTSPICE document, and today I'll be going over essentially a few tips and tricks for running LTSPICE, but also how to run a few simulations. So let's get started. All right, so here's an empty schematic. You see my mouse moving over here. If you press R, you can bring up a resistor. This goes well if you're on Windows or Mac as well. I'm just going to go ahead and make a pretty simple circuit. You guys will see what I'm doing in a quick second. So place this resistor down anywhere, and you can press C for a capacitor. And place this down right here by the resistor. And you can press V for voltage. So put your voltage source. And like with any LTSPICE circuit, you're going to want to place a ground, because your circuit will not run properly without a ground. All right, so everything I just did was part of the LTSPICE shortcuts, which I'm going to write here. Let me see if I can do this better. Resistor, see, capacitor. And you can also, if you want to put an L for inductor, it works the same way. And G. There we go. That's better. All right, sweet. All right, so now you have this simple looking circuit over here. And we actually want to play some more. So if you're on Windows, you should see a pencil toolbar up here. If you're on Mac, just two-finger right click, you go to draft, draw a wire. From there, you can, how LTSPICE works is that you can connect box to box, essentially something like this. But if you wanted to, let's say, just a bit of a shortcut, what you can do is align your components like this and just kind of connect them together, and it should connect everything automatically. So I'm just connecting the circuit as seen here. All right, so first thing that we're going to do is we are going to run a transient simulation, which is for time varying signals. This is actually tran. Yep. And so the format of time tran is basically you have a tran and x, where x denotes the time of your simulation. All right, so first things first, let's go ahead and set some values. So go to your resistor value, set it as 1K, capacitor value, set it as 159. Yep, 159 nanofarads. If you guys will know what this is basically a standard low pass filter. And what we're going to do is set our voltage. So if you want to run a tran simulation, you would need not a DC value, but an AC value. So go to advanced, click sine, and you can do it for a exponentials or a pulse wave or things like that. But for this one, we'll be using a sine. It's a bit easier. So for running a tran simulation, you would actually need this section over here. So go ahead, DC offset, put that at 0. That's basically the average value of your function. Amplitude, that's self-explanatory. So we'll say that that's 1. What did I make? Frequency 10 hertz. It's a low pass filter, so we can go ahead and say this is about 1 hertz. Yep, 1 hertz is fine. Time delay, don't need to worry about that. Theta, no need, and V, which is your phase, and end cycles. So for the most part, when you're running your simulations, you only really need to worry about the amplitude and the frequency. You can leave these blank, as it's not going to affect your circuit very much, since you're always assuming essentially simple or characteristically simple frequencies or sine waves. So go ahead and click OK. And one good habit I like to do is always make sure that the information is visible in the schematic. Make sure you can see it. It's easier to debug and make sure easier for anyone to see what you're actually working on. All right, so after you click OK, you have your resistor value lined up, your capacitor value, your ground. What I recommend doing is actually right-clicking, getting ahead of myself. So the next thing we need to do is actually set up the SPICE directive, or basically tell LTSPICE what kind of simulation to run for how long. So if you're on Mac or Windows, go ahead and press S on your keyboard to pull up this window over here. And we're just going to follow this this notation where we type in .tran and we type in, let's say, 5. So what does this code tell us? .tran tells us we want to run a transient simulation, which is a time varying simulation. And 5 basically tells us that we want the simulation to run for 5 seconds. So let's go ahead and do that. After that, click OK. And once you can place it anywhere, I place it here. Go ahead and right click run, or you can click this running man if you're on the Windows over here. So go ahead, right click it, run. And here you should see a black screen. You can see that our x-axis runs from 0 to 5. That means that our simulation is running our parameters are as expected. It's going from 0 to 5 seconds. All right, so now if you're seeing a red probe, that means you're recording voltage. For the most part, when you run simulations, that's really what you're looking for. But if you want to look for current, you would see this black circle with a red arrow. So voltage, red probe, black circle, current. Keep that in mind. And make sure, okay, so now we have a black screen. Let's go see some outputs. Hover your black probe over V1, the node where V1 is, like right at the source. And we can see our sine wave perfectly as characterized. And we can see that it does have a frequency of 1 second. It repeats about every second here, as you can see here. And now if we wanted to see our output, go ahead and click on the output of this capacitor. There you go. And it's kind of dark, but you can see that it's superimposed into it. And this makes sense. It's a low pass filter, frequency of higher than 1, with a cutoff frequency higher than 1 hertz. So it makes sense that we're passing it through unattenuated or unchanged. So yeah, you've successfully run your first transient simulation. And yeah, I think, let's see, I think that's about it. If you want to see current again, we can see that as well. You can see here. Notice the phase shift between the two. They'll tell you which one's I or current, and I can actually zoom in here and make this a bit better. There we go. Yep, that's a bit more distinct. So here you can see current in the blue line, voltage in the green line. If you wanted to actually measure that specific points, what you would do is you would click the title. Nope, I right-clicked it, don't do that. I would click the title, and then here, you would see this little screen over here. And then you can move this cursor around to follow the actual traces. And you can see the voltage at specific points in time. This is true regardless of what simulation you run, and we're going to go over this again at some point. All right, sweet. That's a transient simulation. And I think that's all I got. Thanks. How do I stop recording?